Okay. Good morning, ladies and gentlemen, or good afternoon, anywhere you are. I'm Nabi Sharadi, President of SOLARUNITED, and I'm very glad and happy. To introduce you our coffee chat today, where we are hosting Manuela Sechilariu. She's a professor at Sorbonne University, and she's going to talk today about PV charging station. We are, as usual, our colleague, partner, Heinz, Antona, and Brian, and Bernard. So please, Manuela, at first, I would like you to introduce yourself, please, and maybe tell us in a few words what you are doing for the PV charging station, and then we're gonna go, as usual, in our coffee chat with a coffee.
Okay, thank you, Navid, for this introduction. So hello, everybody. They say I'm Manuela Sechilariu. I'm professor at Sorbonne, but especially in engineering school, Université de Technologie de Compiègne, France. This is in north of Paris. So I'm also director of a research team, the Laboratoire Avenue, that is an interdisciplinary research team that focuses on electromobility, energy management. So regarding PV charging station, how to implant it in a town, in a city, we need also to have more discipline to participate, to really bring all relevance of this kind of project. So this is the interdisciplinary is important, and this is my research team that I'm the head of this research team. So PV charging station is very important for us, for me as a researcher, but also because we are involved in several projects at the national level in France. Our institutional that found our research is ADEME, and also at international level that we are involved in task 17, and with my colleague Keishi Komoto, we manage this task 17. So I joined Keishi from April this year to manage task 17. But the other years I was a co-leader, and I am leader of the subtask 2 of this project that focuses on PV charging station. What is a PV charging station? So generally we can say it's a kind of carport that we will put many PV panels, but in the same time we need stationary storage, public grid connection. That means we have a kind of microgrid, a local one. The charge will be the vehicles, but we have to manage all this power flow with regards for the energy cost, with regards of the investment cost.
Mm. Good. The PV charging station, as you mentioned, this could be a carport or connected to the grid and all these things. But one of the questions that comes, and the idea that I always have in my hand, is to have the freedom in charging. And how do you see, for instance, the development, for instance, the charging station as isolated in a remote area and all these kind of things?
This could be possible if we take into account that PV power system may be also operate in isolated operational mode. But for this, the optimal sizing of the system is very important, because the batteries, stationary batteries, to be the complementary source for photovoltaic, because it's the intermittent energy sources. So we need this stationary storage in autonomous, it's mandatory. And batteries are on the one side an investment regarding the cost, and on the other side, the environmental foot is not zero. So where is the best trade-off between how many PV panels, how many storage battery? And exactly what is the demand, what is the load that I have to charge, how many time I have to charge what exactly, and for to do what. So I think that it's quite possible to be in an autonomous system, but the sizing is very important to be well optimized. And on the other parts, I think that there are some use cases that we can take into account and maybe others not. All depend for how many kilometers, for what kind of autonomies, and so on.
Yeah, that for sure. I always advocating, or maybe trying to argue against the people for the EV cars, because today we talk about EV cars. EV cars, they are clean cars, but they are not really that clean if we keep charging them directly with fossil fuel, which is completely absurd. We should charge them. If we are thinking about the real clean car, we have to think at first to charge them directly by the sun, or maybe other form, hydrogen. I will not talk about the hydrogen today. Let's focus just on the PV alone. Of course, that if we develop the hydrogen, and think that everybody here will agree that is going to be a real a solution, somehow a huge solution, and a very interesting solution. But we are not there yet, unfortunately. But the PV charging is something which is now has to be developed. And what is the limitation of its development?
I think that regarding the EV charging, if we want that the PV be the most, the contributor, the high one, that means that the end user, the driver, have to change a little bit the behavior. Because if we take a use case very simple, we have a PV charging station based on several PV panels. And if we want to charge 1, 2, or 3 vehicles, so the power of PV panel in real time would not really give enough energy for EV. So we cannot have a battery for a high capacity and to ask also to charge the EV very quickly. So for PV, we have to ask less energy and during more time. So what we show is that if the end user change the behavior and she can charge his electric vehicle each day, for example, for a workplace, carport, in a parking, in companies, that it's possible, or in town near some leisure attraction point. This is possible during some couple of hours to connect its vehicle. And we show that in this case, we can charge the vehicle with almost only PV energy. But if someone wants to charge more than 50% of its battery, that means 25 kilowatt hour, and in 1 hour, and to be only with PV, could not be possible. That involve that you have to have a very, very huge surface of PV panel. So,
yeah, but
yes, please.
No, go ahead, finish.
No, I think that we have to see clearly the reality, how we can grow up PV benefits. And if we want to charge EV with mostly PV energy, that would be very good for a typical, what we call a profile urban or peri-urban, where the driver want to run between 20 and 60 kilometers. So that means not more than 6 kilowatt hour of energy that we can ask. Mm-hmm. So we show in our publication that even north of France, it's not very sunny area, during the winter in December, this 6 kilowatt hour, it's possible to be charged with PV energy during a couple of hours in this kind of PV charging station. And if the driver accepts to charge every day, but as I said, no more than 6 kilowatt hour, that allow exactly to run in between 20 and 60 kilometers. In this case, really PV, it's benefits. And we are more than 17, 18% only with PV.
Mm-hmm. Yeah, that's for sure. You know, I do have a friend who owns a EV car, and they installed the solar panel in order to charge their cars like that. But in my humble opinion, that it's always a trade-off between the consumer, the way how we present the product, and the way how it is. As an example, in the early stage for the EV cars, when they maybe more than 20 years ago, when the EV1 was developed, the game was to have a car, because they found that 95% of the people, they drive less than 100 kilometers. Of course, that we always talk about the autonomy, Yeah. I think that this is in the message that we give to the population and to the consumer widely on the way how we can, our perception of these kind of things. And we have to change in my humble opinion, we have, beside the fact that we are trying to develop the technology, whether it's for the cell efficiency, model powerful batteries, and I would say fast charging, because there are also some solutions. For instance, we look into the battery as the energy storage. We can look into the other things for other type of batteries that they are mainly a power storage that could be a fast charging for the cars. So it's always in our way of introducing and making, I would say, awareness around that question, because at the end of the day, if we want to go something which is clean, we have to think clean also. But taking that solution of EV cars as it's used today, in my humble opinion, useless. And personally, when I have hesitating to buy a car, I just bought a car recently, and I was asking myself, which car shall I buy? But unfortunately, I bought a thermal car.
Yes, okay. Unfortunately, because
I took a hybrid car, plug-in hybrid. That's half the way. Yeah?
I hesitated for long, but I was not satisfied with the brand of the car that I wanted. They don't have really a very nice system. So I decided, and I went for a thermal car for the time being. I know that I'm going to use it for maybe 5-6 years, maybe less, but I was not convinced. With that idea of the EV cars and the way how we charge them today.
What I'm missing with my at my plug-in car is actually an DC input to connect the module directly, because I charge it with a 2 kilowatt socket at home, which makes it full in 4 hours. So that's something we get in the range of what we are talking about on a carport. Unfortunately, if I would charge it through a carport, I would still need a battery in between and an inverter. So
no, we can use both. We can use DC, we can use AC. Yeah. So when we use a microgrid based on PV, the interest is to look at the overall system efficiency.
Yeah.
So we have to have less conversion stage, less power converter, to have less losses. So DC to DC, it's more efficient than DC, AC, and again DC inside the vehicle. So please.
What we all in this chat always are driving around is in principle this promise of photovoltaics to provide clean electricity for electric cars, or the other way around, is an electric car can be only as clean as it gets when you have photovoltaics or when it's operated in France. So, or in Switzerland with a lot of hydropower. And so, but we have countries where basically driving an electric car has as much as CO2 emissions than a normal internal combustion car. Now, but we are getting there, and you say this, and I would be interested also in your experience regarding microgrids. And I'm not thinking of carports, I'm thinking of big supermarket marketplaces or shopping mall parking places, but even the current gas stations. So if you drive through Switzerland, you find all this nice, at least 8 Tesla charging stations, plus some others, but never a PV roof on it. So what do you think? Is there a technology barrier still, or is it, as you're saying, behavioral changes? So I certainly, if I would know in Switzerland, Campagnolo has a PV roof, then I would charge my kind of Campagnolo and not elsewhere, for example.
Oh, what we can say that today, not only in France or Europe, but around the world, the most of this kind of PV charging stations, they are not really charging stations, they are PV carport near train station, airport, and so on. And due to the incentive policy and or kind of regulation for each country, PV energy is injected into the public grid.
Yep.
And building or EV can charge from the power grid.
But is it correct if this is subsidized? I mean, wouldn't it be better if the electric car, which is subsidized, a certain fee of the car goes into installation of a PV plant, no matter where it is? And then you can virtually make sure this is additional PV energy on the grid, which corresponds to your consumption.
Yes, you are right, but this must. This is the point of view or the reading angle, point of view. If you think about energy, and it's okay to see it like this, but the question for public grid everywhere around the world is the power. That means at exactly instant.
Yeah.
Am I enough power to do something or not? For my own car, for my own house, or for my city, or for my country, or for Europe, because we are all interconnected here for the public grid. So the question is the power. So how can we do this? And regarding the power, I just make some calculation with the French public grid about the total installed power, supposing that all work, all are operating, because now there are some reactors that do not work because they are in maintenance. And suppose it that all work, okay. And suppose it that in 10 years that the global outlook of EIA and others say to us that electric vehicle will be everywhere. So 15 million of electric passenger car, if only 10% would like to charge in the same moment. And if it's for a 22 kilowatt charging point, that is very usual everywhere. So that means more than 35% of the installed power in France, it's only for this. So it's not possible. It's not possible. We have to work in another manner. We have to see how to do it in a manner that could be feasible, credible for all kind of use of energy, electric energy, because energy will be, and it is, and will be, I think, starting September, a big problem.
I was once on a roundtable asked, in your view, what changes in our cities when we have, instead of combustion engine, only electric cars? And my reply was, basically not much. It will be still crowded and full of traffic jam, but in addition, you would need an 800 megawatt power plant right in the city. Is that more or less going in this direction? Hello? You lost me?
Oh, Heinz, you're still there.
Yes.
I lost you for a moment, so I do not know if you say something. My connection was not good, maybe.
No, I just said, was an anecdote. I was once on a roundtable asked, how do our cities change with the electric car? And I said, well, they're pretty much the same traffic jam, but in addition, we have an 800 megawatt electricity power plant in the city.
Yes, it's not possible not.
And if you say 22 kilowatt, 800 megawatts, so that's 400 cars. Huh?
Also, based on this calculation you did on consumption for only 10%, but if we imagine that all electric cars that are not driving, they are plugged in, it's a lot of, let's say, power. If you can have a bidirectional station, meaning you can charge from maybe PV during the day, but then supply the grid with your car during the night or when other cars need to be charged, then you can balance, because 10% can be charged, but 10% can be uncharged to a certain level, and then it can be balanced much easier than to have a centralized production of electricity. What do you think about that?
Yes, it's one of the strategy that we can work on for the concept of vehicle to grid, because vehicle to grid in the context of the smart grid, if we receive messages about this constraint, and the grid can evaluate exactly how many vehicles are connected, and during a short period, they can inject battery and also the PV, if they are in a PV charging station, into the grid. And on the same time, maybe other vehicle can charge if it's more congested, the grid in area, nearest area, but not in the same area. So these are the strategy that can be put it in the reality and tested. But there are many problems regarding the communication at a good moment, and each time the driver have to accept or not to do it.
You know, Antonin, I have a friend at the Coton, in the Canton de Vaud, just on the top of Morges. You know, he's installing such system that can go in both ways. From his rooftop to the car, to his EV car, and from his EV car to the home, to the house. He's installing that at Coton. and the amazing thing is that when he asked for a company to install this, they told him, no, this is impossible. We cannot do it. He insists very hard, and finally they came out with such solution, and now they are installing that Coton.
Yeah, and even in Canton Neuchâtel, which is maybe 30 kilometers away, the regulation not allow electric car to supply the grid. So you see, I think we have to work hard.
Well, this is unfortunate. Paint it as a Tesla wall, then it's not an electric car anymore, or something. Maybe then it's louder.
Yes, absolutely. Maybe, but this is unfortunately is some, I would say, absurd regulation in Switzerland. That's you have to pass by the grid automatically. You cannot just feed yourself like that. In kind of blackout, then you will have problem, and we will have problem in Switzerland in such way. You cannot really just get it by yourself. It's very complicated. So in terms of the regulation, that has to be really developed. Well, I will not talk here about Switzerland and the problem and what's going on, but it's very interesting that we can have also that idea going in both ways.
Yeah, of course. Both ways are on work. We work on vehicle to grid, vehicle to home, or vehicle to building, because you can imagine also PV charging station, but in fact the PV are installed on the roof building that could supply the building, but also to charge electric vehicles. So also electric vehicles, if are connected can discharge into the building, and could be feasible also.
How do you see the development of the PV station across Europe, across the world? What would be the outside pace of its development?
I think that when it's possible to be installed, that means large parking, especially, that will be certainly well employed and mass deployed, because effectively we need it. And when the price of the electrical energy from the public grid will be higher than nowadays, I think that will be really a mass deployment of this kind of structure. For the moment, at my knowledge, talking with stakeholders about the PV charging station that they install in France, okay, but all the PV production is injected into the grid. They do not associate with the power controller and the supervisor to have interface and control to charge directly with the PV energy electric vehicle. They always inject in the public grid, and the public grid do not require every time this kind of injection, and it's issue for the public grid to manage all this injection. So will be transformation in this way also.
Yeah, but if we look into also installing, because today there are companies where they are renting a roof from homes, and then they are installing the PV, and they are paying a rental of your roof. Why such business model cannot be developed, for instance, for the carports as well?
This is one of the questions that I ask from several months and even year, because I cannot have a good business model to show economic side of this PV charging station, what can be really the return of investment. How can we be better on energy price regarding the energy price that we have now from the public grid? My own electric car, if I make my 200 kilometers from Paris to Normandy, so 200 kilometers, I have to charge when I arrive in Normandy, and I pay €4. It's nothing.
Yeah.
So when the business it's go on to invest in PV, in storage, in controller, in and so on, so the price will not be €4. So for the moment, we have not the good business model to do it, I think, and especially in France, or the electric energy prices, it's quite low.
Yeah, I think, in my humble opinion, that the public sector will be the motor drive for that, because the public sector, they have a lot of parkings, a lot of I would say that they can make them I would say with carports, and they can really subsidize, for instance, because it's a benefit. Today we are looking and we are facing a huge problem with the power. And this is the reality, and that reality will become worse and worse and worse, because we're going to increase, we look more and more in the EV cars. Okay, that is going to make really generate big problem on the grid itself, in terms of, when everybody wants to load his car. We're going to need more and more electricity for the coming years, because our need is continuously increasing with all this crisis. Of course, that there is never the right moment, and what is the right moment to invest in something like that. But if really the government, they are serious in their mind and their talk today, when they are all of them talking in the news, whatever, to consider this kind of, I would say, possibility, opportunity to develop that, and also to show to others to show to others. Sorry if I always come back to Switzerland, because as Heinz mentioned it in the beginning, for their carport, the electrical car or the boats, also the solar boats, there are some carport that I know since, I would say, mid of 90s in Switzerland. In Switzerland, that's Switzerland, not all Switzerland, but just in Lausanne, Lausanne carport, and they are working until today. And these are private. Private. I think that's the public sector has to open the eyes and make real actions on that.
Yes, I think you're right, and this is the reason why we work together also in our project with some council town, because they must be involved more and more in this kind of project and for all this idea. But about what you said regarding the private PV carport, there exists from 20 years ago, but it was also years when to sell PV energy to the public grid was a very good business.
Yeah, absolutely.
So this is why exists still now, because was also some kind of contract for 20 years.
Yeah.
In France, I have example for this. So my point was this, that we have this PV carport, but PV do not charge EV. PV just inject into the grid. Not all, but mostly of.
Yeah.
We have to change a little bit, but I think that it's a very, very high way to go through this one. And about what you said just at the beginning, because I think that is the end, about hydrogen, it's not the subject for today, but PV have a contribution, because if you think just a little bit for electric buses, that all towns are now with electric buses, and it's a huge problem for the public grid. So PV on the depot of electric buses will produce hydrogen, but they can,
that's going to be the great. That's really the great solution if we can combine this and make it. But in terms, of course, that today we talk about cost, but I'm pretty sure with the deployment, is going to follow more low and is going to decrease drastically quickly, as we use in each single domain.
Yes, certainly. But I think that the word that we have to say that we need a mix, even for electric mobility. We have to keep in mind that a mix, hydrogen, battery, we have to do a part of all of this to really cross out of this transition, energetic transition.
Yeah. Well, you know, the technology never disappear. It just, I would say, moved a little bit aside and keep using. The Stone Age never ended up.
Yeah, you're right. Disruptive technologies are not all the years, every year.
Exactly.
Not every decade, not ever.
Exactly.
Yeah, you're right.
Yeah, well, I don't know if Heinz, Antona have something to add before Brian conclude.
Yeah, maybe something to raise that also when you go to high power charging station, the price of electricity is clearly not what you get from your plug. So there also to have maybe a combination between these charging station. I don't know how to manage this, having also some storage nearby this and to balance. And this you can have maybe a return on investment. I don't know if could be a business model.
Of course, because when we ask a high power and fast charge, the price is not €4 that I gave you as example. So it's more expensive, and this is a charging point that we have in our tollway in France. But for the moment, all these ultra fast point charging, they do not always work at the power that they put it out. If they say it's 50 kilowatt, when you charge your vehicle, it's not really 50 kilowatt, it's almost 30. So it's not very fair for the moment, but I think that will be better in 2 years. But that could be this combination could give certainly a business model that could work also to be convincingly for some companies to implement it.
Thank you.
Heinz, maybe last word.
Okay. I really hope that we're making progress in this, because the combination of photovoltaics and electric cars is a big promise in the society and a big change to everything what we had the past 50 years. And I think it's good that we have with you also a person who knows both worlds and sits right in the middle in the distribution of the energy to it. And hopefully these microgrids and charging infrastructure, which is new to us, will eventually replace gas filling stations. So I'm always wondering how long did it take until gas filling stations are there. Then we see the dimension of this. And I never forget that a gas filling station, if you put the nozzle in your car, this is the power of 10 megawatts. So just to get the idea of what we are facing. So thank you very much for my answer.
Thank you.
Well, I think maybe here is maybe a good point to wrap up the session. These sessions are always enjoyable for me, and I generally get quite a bit of information that maybe I wouldn't have gotten at a different conference because of the format of this particular coffee chat. Manuela, thank you so much for participating today, and special thanks to the IEA Task Force 17 for all of the great work that you guys are doing there. Just as a reminder, we are trying to do these sessions quite often. We have our next session on June 8th, which will be at 2 p.m. CET. Participating in that next session, we're going back to the topic of VIPV with Bertrand Chambillon. I'm sure I'm not pronouncing that 100% correctly, but he's from CA INES. You're welcome to join in to that session as well. More information will be sent out soon. But in general, thank you to everyone. Nabi, Heinz, Antonin, you did a great job today. And thanks for those that participated with us live, and also for those that are going to watch the replay later. So thank you very much for your time, and I wish you all a great day.
Thank you all.
Thank you so much. Bye-bye.
Thank you.
Thank you.
Bye-bye. Bye-bye.